All right, so 5.2, we're talking about rational exponents. And last module, everything had to do with rational things, right? So remember, when you have something that is rational, it means it can be written as a fraction. So if you want to think of these as fractional exponents, that would be good, because now we're going to be using those exponent rules that that are at the beginning of this, of all of the lecture notes in Module 5, and we talked about them before back in Module 3, but now we're going to come back again, and now we're going to be dealing with fractional exponents, but those same rules still apply. So let's review over some of those rules to remember. So if I have a power raised to a power like this, right, x to the third all squared, and so, they have these parentheses here, power raised to a power. Well, that's going to be x to the sixth, because it's basically saying I'm taking x to the third times x to the third, and then if I write those out even more, well, x to the third is x times x times x, and the other x to the third is x times x times x, so that really gives me x to the sixth. Right? And so we can see that we've got to multiply those two together to end up with x to the sixth. All right, now here we've got our base is 3, but still the same thing happens on this. We're taking our 3 and now we're raising it to the sixth power, right? Because I'm still doing 2 times 3. And sometimes they might have you figure out what that is. It's going to be a pretty big number, or they'll just let you leave it like that. So just check and see if it says you can leave it as an exponent or not. Okay, so getting into our fractional exponents, I want you to see we're still multiplying these together. It doesn't matter that one's a fraction and one isn't. So I'm taking that 1/2 and I'm timesing it by 2, or really that's 2 over 1. And so remember, when I multiply exponents, I multiply across the top, and then I multiply across the bottom. So I've got 2 over 2, so that simplifies to just be 1. So that means that I end up with 3 to the first power, and 3 to the first power is just 3 for our answer. Okay, so don't let those fractions freak you out too much. Go back to those properties of exponents and make sure you know, am I multiplying my exponents together? Am I adding them? Am I subtracting them? What am I doing there? Okay, and we'll talk about some of those as we're going along here too. Okay. All right, so let's see. Oops, I didn't mean to do that. All right, so a rational exponent. Let's just put a little definition here. I kind of said it in words before, but let's just put it down to make sure you remember, right? Is an exponent that can be written as a fraction. So something like x to the 3/2 power, right? So that 3/2 is a rational exponent or a fractional exponent. All right, let's take a look at some things here, because there is something that I kind of want to point out to you here, and hopefully you can see. So we've got this number, 32 raised to the 1/5 power. So our fractional exponents can be written as radicals. Right? So that's why we talked about radicals in 5.1, because now we're going to take these and we're going to change them to radical form to help us simplify. So here, if I change this to a radical, it would be the 5th root of 32 to the 1st power. So notice that that denominator tells me what my root is going to be, that, type of radical or the index, and the numerator of that fraction is going to be the exponent inside. Well, 32 to the 1st power is just 32, right? And then I can just do what we were doing on the other one, right? Break down 32. So 4 times 8, breaks down as 2 times 2, and you probably should just have memorized that 8 breaks down to be 2 times 2 times 2, because you're going to see it a ton. So we really have the 5th root of 2 times 2 times 2 times 2 times 2. And remember, we need 5 of the same in order for them to come out, and we have 5. So they all get to come out and be a 2. So 2 would be your answer on that one. Okay. All right, let's take a look at, let's go over here to E now. So this one is negative 64, all raised to the 1/2 power, or sorry, to the 1/3 power. So on this, right, that 3 is telling me what kind of root it is, so I've got a cubed root of negative 64. And, these, if they're perfect cubes, you can go ahead and put them into your calculator and you'll get an answer there on it. But 4 times 4 times 4 is 64. So if I have negative 4 times negative 4 times negative 4, and I do the cubed root of it, that's just going to give me negative 4 for my answer. All right, so again, we've got a root that is odd, so I can find the answer to that. And then on this one, let's see, actually, I wanted to do one. Wanted to look at C and D on these, because these really, I want you to see there's a subtle difference between C and D, right? C doesn't have parentheses around it, and D does. And that changes the problem totally. Because on here, on this first one, we really have this negative is negative 1 times 81, 1/4 power. So only 81 is being raised to that power. Negative 1 is not. Right? So when I write this out, that negative 1 is going to go out in front. And since the denominator is 4, I'll have the 4th root of 81 inside. Right? So the 81 is just inside, the negative's outside because of how it was written here. Now, I'll solve this in just a minute here, but let's contrast that to this. Everything, right, is being raised to the 1/4 power, so that's telling us that we're trying to find the 4th root of negative 81. Well, we just got done saying we can't take the 4th root of a negative number. Right? They can't be any even root, square root, 4th root, 6th root. And so this answer is going to be D and E. We can't do that. However, we can simplify this one up here. Right? Now, 81, if I break that down, is 9 times 9, and then each of those 9s break down to be 3 times 3. So I get 3 4s inside here, and so all of those 3's get to come out as a 3. But I still have that negative 1 that I need to multiply by, so my final answer on that would be negative 3. All right, so when it's written without parentheses, I can get a solution. When it's written with parentheses, I've got that even root, I can't find an answer there. It doesn't exist in the real number system. All right, questions on those? You know, sometimes the difference between that C and D can sometimes be a little bit weird and, you know, maybe confusing a bit until you have more practice with them. All right, well, let's keep going. If you have questions, please make sure you ask. All right, so on the last question that we did, all of the numerators were 1. But can you see on these, we're now going to have numerators that are not 1. And so we've got to figure out, okay, what do I do with those? So there is, if we have something in radical form, so I've got the nth root of a to the m power, then we can change that to a fractional exponent to be a to the m over n power. All right, so on this you might think, oh man, that might be hard to remember, you know, which one of these goes on top and which one goes on bottom. But I did have a student one time tell me how he remembers it, and so I'd like to pass it on to students. He said, well, he thinks as this, you know, little division bar here is the ground. And, you know, so here's the tree that's above the ground, and below the ground are the roots of the tree. Right? And so he just remembers that the bottom, right, underneath the ground, is where the roots are. This is our root. Right? And it's on the bottom part of the fraction. So again, it's just a kind of a silly way to help you remember this, but hopefully it'll, you know, help you with that. Now I do want to point out something else on here. If I have a to the m over n power, right, I said I could write it like this that I have, but it also could be written as the nth root, right, because that's my bottom number, the nth root of a all raised to the m power. So meaning that m could go inside, be the exponent on just that a, or it's the exponent of everything. So both of these are correct. It's just a different way to write it. And sometimes having it written one way or the other will make it easier to simplify it. All right, so let's do a few more here. Make sure that we have an understanding of what we're doing on this. So if I'm changing this to radical form, my root is 2. I don't have to put that 2 in, but I'm going to put it there just so you can see where things are going. And then I've got 25 inside, and that's all raised to the third power, whatever that numerator is. Okay, now remember, you could have it, and I'm going to put this over here, we could have the square root of 25 raised to the third power, where that 3 is on the inside. And I just want you to see, you will end up with the same answer. I like it this first way that I wrote it because I can do it this way in my head where I can't on the other way. So I'll show you what I mean. On this one, it's telling me to take the square root of that number first and then raise it to the third power. Right? That's what these parentheses are telling me. So the square root of 25 is 5. 5 raised to the third power is 125. 5 times 5 times 5. All right, on this one, now I've got to multiply. It's telling me on here, multiply my 25 by 25 by 25. All right, and I get this really big number, which would be the square root of 15,625. All right, and I don't know what that is in my head, but when I work it out on my calculator, I find that it is 125. So either way works. I just prefer this way because I can do it in my head. But either way is totally good. All right, let's do a couple more here. Let's do both C and D on this. So again, this negative out here is like a -1 times 16. So let's write it down that way. It'll help us. And then that's just the 16 is being raised to the 3/2 power. So I've got -1 times the square root of 16, all raised to the 3rd power, right? And this is multiply here. And so I've got -1. Well, the square root of 16 is 4, and then 4 cubed I still have to do there. So -1 times 4 times 4 times 4 is 64. So that means that my answer is -64. Okay. Where on this one, right, this is inside that -64, everything's inside. So when I write this, I've got the cubed root, so I'm going to put a 3 out here, of -64 all squared. So the cubed root of -64, I'm thinking what times what times what equals -64, which will be -4. And if I take -4 and I square it, -4 times -4 is +16 for the answer. So just watch those order of operations closely in order to make sure you're simplifying these correctly here. All right, still going to do a couple more problems here. I know we're kind of at time, but hopefully you're able to stay on a little bit longer to do a few more of these problems together. All right, so this one is talking about negative exponents. And so negative exponents, oftentimes it's where kind of some trouble is because people are kind of thinking about them in a weird way. So I want you to think when you have a negative exponent, it's telling you to flip me, like flip the whole base is what we're flipping. So I'm going to put 81 over 1 to help me remember that that's my fraction that I'm going to be flipping, right? So notice up here in the definition, it basically just says, you know, if a to the m over n is a real number, then a to the negative m over n is going to equal a to the, sorry, let me put it this way, 1 over a to the m over n power. So we flip what the base is, but then our exponent is staying m over m and is just no longer negative, right? So when we flip that inside, that is what's changing that negative exponent. Okay, so let's try it on this one. So again, I've got a negative exponent, so I've got to flip my base. So I need to have it as 1 over 81. And then this is all raised to the 3/4 power. All right, so notice that 3/4, your -3/4 just changes to 3/4. Just like we were doing before, if I had a to the -2 power, I said that is 1 over a squared. Right? I flipped it down into the denominator to where it was going to be happy. And on this one, I guess technically it doesn't really have parentheses around all of it, but on this one it doesn't make a difference. But I should put it down this way: 1 over 81 to the 3/4 power. Oops. Okay, so now let's change that to radical form. So I got 1 over the 4th root of 81 raised to the 3rd power. Right, so remember my root is 4, so that goes here. And then that top number is my exponent on this. I've got 1 over the 4th root of 81 All right, what times what times what times what equals 81? Well, that's 3. And then I still need to cube it. So 3 cubed is 27. So 1 over 27 would be my answer on that one. So first start by getting rid of that negative exponent by doing the flipping, and then change it to the radical to simplify it. It'll be easier that way to do that. Okay, let's see. Let's do part C, because this B is going to be really similar to what we did on part A, but part C is a little bit different because now this whole thing is being raised to this negative 3/2 power, right? I've got this fraction being raised to that power. And so remember, I'm just flipping the base. So my base is 64 over 25. So when I flip that, I have 25 on the top, 64 on the bottom, and now that's all going to be raised to the 3/2 power. Right? It was negative before, and now changes to a positive because we flipped it. Okay, but be really careful. A common mistake is people try and flip this rational exponent. That doesn't flip. Right? It just goes from a negative to a positive. All right, and now I can just look at these and say, oh, both of these are being raised to the 3/2 power. So I could write these in radical form, the 3/2 power. So 25 here, 64 here. It's a square root. All right, maybe I'll put these 2's in here to help us remember. And then all raised to the 3rd power. So let's see what we get there. Square root of 25 is 5 raised to the 3rd power. And then square root of 64 is 8 raised to the 3rd power. And then it might want you to simplify that more. 5 to the 3rd power is 125. And then 8 to the 3rd power, 8 times 8 times 8 is 512. And then that would be our answer. We know it can't simplify anymore because up here, right, this was 5 times 5 times 5. This is 8 times 8 times 8. And they don't have any common factors that we can divide out. So that is what we'd be left with for our answer. All right, let's do a couple of these. Look at a couple of them where we have some exponents. But notice on this one, it says, assume all variables represent positive real numbers. So that means we don't have to use the absolute value. When it says that they're going to be positive. We don't need to use that absolute value sign. All right, but let's look at this, because this is where sometimes it gets a little tricky for people. Remember, like this 5 is saying 5 times x to the 2/5 power. Well, just the x is being raised to that power. And also, this one's just saying write them as a radical. It's not telling us to simplify anything on here, just to rewrite them. So 5 is separate from it, right? And if I write this x to the 2/5 power, x is inside, 5 is my root, so let's put that here, and then 2 is my exponent on it. So that would be my answer. Or if you wrote it as 5 times the 5th root of x. Now just this part would be all squared. You can't include that 5 as part of it if you write it this other way. Because remember, just the x is being raised to that power. Okay, on this one, again, we've got to change that negative exponent to a positive exponent by flipping the base. So I get 1 over x. And now it's no longer to the negative 5/7 power, it's to the positive 5/7 power. Right? But I'm not done yet because I haven't written it as a radical. So let's keep going and let's write it as a radical. So I have 1 over, and then my denominator is 7, so the 7th root of x to the 5th. So 5 was my numerator. And then I'll leave it like this. It's not telling me to simplify anything, just rewrite these. And then kind of similar on this whole thing is in parentheses, so that whole thing is being raised to the 1/3 power. So that means I'm going to have the cubed root of everything inside the parentheses. So x squared plus y squared, that whole thing. And that would be your answer on that one. Okay, so on some of your questions, it's just going to be rewriting them back and forth, making sure you know how to take a fractional exponent, write it as a radical, take it from a radical, write it as a fractional exponent. So that's what we're doing on this one, just taking them and writing them as a fractional exponent. So on this one, right, remember we've got a 2 here and a 1 here. So this is 37 to the 1/2 power. This one, we have 9 as our base, raised to the 8/4 power. But then if it wants you to simplify here, it might not, this could be your answer if it tells you not to simplify. But if it wants you to simplify more, 8 divided by 4 is 2, so it's really 9 to the 2nd power, which is 81. So just notice what it's asking you to do. And it'll be very specific. It'll just say rewrite, don't simplify, or something like that. And then this one, right, if we have this, we've got, the 8th root of x, or z to the 8th power. So I've got z to the 8/8 power. And then if it wants me to simplify, 8/8 is 1. So I have z to the 1st, or just z. So again, sometimes that's all it's going to ask you to do. Just change it from one form to the other. Okay, so this is kind of the last part that I want to get to, because now we're going to have to use those properties of exponents to simplify these. Changing them to a radical on these isn't going to help us simplify it. And so, like on this first one, remember if I had, x squared times x to the 3rd, right, when it's connected by multiply, I add those together. And it's going to be the same thing here. It's connected by multiply, so I need to add those exponents. Let me write it this way. So it's going to be 3 to the 1/2 plus 1/3 power. Right? And then I've got to simplify that. Well, if your calculator will add those up for you, that's fine. If it doesn't, then remember you've got to get a common denominator, which is going to be 6. So I need to multiply this by 3 to get 6. And so multiply the top by 3. Here, multiply the bottom by 2, and the top by 2. So that gives me 3/6 plus 2/6, which gives me 5/6. All right, so that's what I'd end up with here, 3 to the 5/6 power. All right, so it's the same idea, right, like we were talking about over here. However, whoops, I didn't mean to put it there, here. But here we didn't have to deal with fractions and find a common denominator and everything. So that's the one thing that's kind of different on these. All right, when things are connected by division, we subtract them. Right? If I had, what's my cursor here? Where is it? Okay. So if I have x to the 7th over x to the 3rd, we subtract those and get x to the 4th. So we're still going to subtract on these. We have 7. It's always the top exponent, so 2/3 minus 4/3. Well, on this one, we already have a common denominator. Hallelujah, right? We don't have to go find it, but let's go ahead and subtract them. So 7, 2 minus 4 gives me -2. And then 3 is left in the bottom. Okay, but this isn't all simplified yet. So one of those rules up top where I was talking about simplifying these exponents is that if it's a negative exponent, it's got to be positive to say that's all the way simplified. So again, this is like 7 over 1. That negative exponent's telling me I need to flip it. So I've got 1 over 7. And now 7 is going to be raised to the positive 2/3 power, not negative. And then you could just leave your answer like this. It's not wrong to change that to a radical, but usually if your question starts off with fractional exponents, they'll want you to leave it as fractional exponents unless they're specifically asking you to rewrite them as radicals or simplify using radicals. Okay, I'm going to skip C and let's go down to D, just because D has a little bit more going on, and that way we can make sure we've got this. All right, so I notice first of all, everything is being raised to a negative power. So that means I want to flip everything inside so it can be raised to a positive exponent. So we flip it and keep everything just like it is. So meaning all of this is going to go on the top just how it is, right? So it becomes a to the -2, b to the 1/5. All right, I don't change that -2 yet because I was focusing on this outside negative. That's what I'm changing right now. So let's just do this one step at a time. And then on the bottom, I get a to the 3rd, b to the -4th. And now, right, that -1/2 becomes +1/2. So this is all going to raise to be a +1/2 power. All right, now I'm going to flip. I don't like working with negative exponents. You probably noticed as I was doing it. I just think there's just more chance of having mistakes when you have those negatives. So I just like to flip them to where they're going to be happy, where they're going to be positive. All right, so a to the -2 power is not happy upstairs, but if I flip it downstairs, it's now just a to the 2nd power. All right, b to the 1/5 power was happy upstairs, so let's go ahead and leave b to the 1/5 power. On the bottom, a to the 3rd was happy there, right? It's a positive exponent. But b to the -4, it wants to go upstairs to be b to the 4th. And it's still all raised to the 1/2 power. Haven't used that part yet. At this point, you could distribute that 1/2 power through to everybody if you want to, but that's just going to give you fractions kind of everywhere. So I would rather combine my b's together and combine my a's together and get everything together on the inside. All right, so if you need to, so this b to the 1/5 times b to the 4th. Remember, if it's connected by multiply, we've got to add those exponents. So I'm just going to do a little side work over here. So b to the 1/5, all right, plus 4, or 4 over 1. And then I need to have a common denominator, which is going to be 5, so I need to times both of them by 5. So I have b to the 1/5 plus, now I've got 20/5. And now that both of those are the same denominator, I can combine those to be b to the 21 over 5 power. All right, so that's what I have on the top here, b to the 21/5 power. On the bottom, these are easier to put together, right? It's connected by multiply, so I add those together, so that's going to be a to the 5th. But now, I still haven't used that 1/2 power. Everything needs to be raised to the 1/2 power. So again, when I am dealing with a power raised to a power, I'm multiplying. All right, so with this one, it was connected by multiply, so I add them. When it's power raised to a power, I need to multiply them. So maybe I'll put this over here. If I have 21/5 times 1/2, we just multiply across the top and multiply across the bottom and get 21/10. So b to the 21/10. And then on the bottom, I get a to the, remember I've got 5 over 1 times 1 over 2. So I get 5/2 power. So a to the 5/2 power. And again, it started off, with these fractional exponents in it. So you'll leave it with fractional exponents in your answer here. Like I said, it's not wrong if you change it to a radical, but you just don't have to. So just don't have to take it any further than that. Okay, questions on that one? I know it was quite a lot. Anybody follow that or have anything else that you wanted to ask there?
No,
I feel good.
You said you're good? Somebody else? Okay.
Yeah, I'm good.
What about everybody else?
I'm good.
Yeah?
I'm good.
All right. Okay, well, we'll stop there. I am going to, I was hoping to get some videos posted this weekend, but since I wasn't feeling well, I didn't get that done. But I will get videos for 5.3, 5.4, and then I'm going to try and get 5.5 done also, so that next time we can talk about 5.6, 5.7, and 5.8, hopefully. Okay? All right, guys, have a wonderful night.
You too.
You too.
Thank you.
Good night.
Good night.